Okay, now let's talk about the subsetting. So we learn about subsetting, right? When you're talking about the vectors, right? But extracting the subsetting the elements from matrix in R is much like extracting elements from vectors, right? So, yes. So let's talk about subsetting, right? Subsetting the elements from the matrices. Okay, not from vectors, right? We already talked about subsetting, right? Subsetting the element, like extracting the elements from the vectors. Okay, now go to next page. Okay, you know that you must be performed with the row and column positions. So basically, to pinpoint, right, pinpoint the element in the matrix, you need to use a square bracket, and then what is really important thing is it's really start from the row value. Okay, so row, right, and then what, column. Okay, and so this is like we already learned the matrix functions, right? And then for the data, you provide this vector, right? And the dimension of this matrix is 3 by 3 matrix, right? 3 by 3 matrix. So as you can see, this is 3 by 3 matrix. Okay, now let's just create this matrix. I mean, I really don't like this number, so I'm gonna use a different number, but I'm going to create the 3 by 3 matrix. Okay, let's see. Okay, yeah, maybe I can use this. Let's see. So I'm gonna see the row is a 3 by 3, right? And then if I don't use by row, right? By default, it's by row is by default is false. That means it's a column wise, right? The column wise. So the matrix is built in a column wise fashion. Okay. So you know what? Just in case, no. Okay. So then let's see. 3 by 3 matrix. So the total number of elements in the matrix should be 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Okay. So instead of using this number, right? I don't really like this number. So I'll just use this simple integer. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then 3 by 3 matrix. And then execute this, right? So as you can see, this matrix is created, right? And then in a columnized fashion, right? So the first 1, 2, 3 is this column, right? And then 2, 4, 5, 6 basically used to create the second column. And this is for the third column, right? So this is the columnized fashion. Okay, so okay, you know what? I'm gonna create a new variable a, right? And then this new variable a will be contain this matrix, right? So let's run this one more time, and then I'll say a, and then run. Yep. So the variable a now has this matrix. Okay. Now, if you want to pinpoint, let's say this element, the 5, right? I mean, let's say 6. Okay. So what is a row? Row is a 3. And then column number is a 2, right? So if you want to pinpoint that particular element, A, okay, sorry. A and what? The third row and second column, right? So this should return 6, right? Okay. Now let's say row and column diagonal extraction. Okay, so now to extract the entire row or the columns, right, from a matrix, what you have to do is what? Specify the desired row, the column number, and leave the other value blank. And then, of course, you have to use a comma. So, for example, if you look at this, right, and you know that this means, hey, I like to get the basically the A. Basically, it says I'm going to get all the row, right? But so that's why this row field now is leave it as a blank, right? And then the 2 means second column, right? So basically, this means, right? Basically returns the second column of A. Okay, you know that. Okay, so now this is the what? So this is the matrix, right? Second column should be 4, 5, 6, right? So it should return 4, 5, 6. So A, and then mean, okay, so I leave the column, field blank, and then comma, and then 2, right? So that means I like to get all the row, right? But basically it returns a second column, right? So when I enter, it should returns 4, 5, 6, right? The 4, 5, 6 is a second column. Okay. Okay. So now the following examine the if you want to, let's say if you want to examine like first row, okay, regardless of the column. So in this case, let's say if you want to observe this third column, right? I mean third row, which is a 3, 6, 9. Then what you have to do is A, and I want to observe the third column, and then all the column. Okay, so just leave it as blank, right? So this returns the third row, right, of matrix A, right? So run this 3, 6, 9. Okay, the third row. Okay, and let's see. Oh, and then also you can specify not okay. And then the next page, the last one is okay. Another important thing is this. Note that whenever extraction, right, extraction result in a single value, the single row and single column, right? And I will always return the standalone vector comprised of this request value. So, okay, this is very important. Okay, I want you to know that it's okay. I want you to know that it returns what? Standalone vector comprised of the request values, right? So the key word is standalone. Okay. Key point is what? Standalone vectors. So that's the key. So for example, in this case, right, this result is a vector. Okay, it's not a matrix. Okay, so this is something that you should know. So whenever you do the extraction, the result is what? Either single value, right, or the single row. I mean, all this is basically is a vector, right? The type of the result is a vector, right? It's not a matrix. Okay. Now, another example is they use the colon, right? So, for example, requesting the whole row. Okay, I mean you can actually request the multiple rows and the columns, right? Where the result must be returned as a new matrix. Okay, so this is another important thing, the concept you should know. Okay, so basically, right? I need to pen. Okay, so you know that in this case, right? They are this is like a single element, right? And this is a single basically column, right? Second column, and this is the first row, right? In these three cases, for example, right, the return value is a standalone vectors, right? In these three cases, for example. However, let's take a look at this. When you ask for the multiple rows and columns, for example, like this means what? A second and third row, right? The second and third row, right? In this case, is multiple rows, right? In this case, result must be returned as a new matrix. So you can see this is like a new matrix, right? So there's a big difference between this and like this example. So, and if you look at another example, right? This means returns what? The third column and then return the first column regardless of the regardless of the row, right? So it really shows that what? It shows, if I see the next page, it shows that basically, right? Oh, right. Yeah. So just clear the screen. So basically it shows the third column, right? And then the first column. right? So basically this return value is, the type of the return value is what? It's the matrix, right? And let's take a look at this example. So it returns what? Multiple rows and multiple columns, right? And this is what? The third and the first row of A. Third and first row of A, right? And then second and third column, right? Starting from the second and end with the third. So basically 2 columns. So this is like a second and the third column of A. So you are, okay, so let's just do some experiment with this one, right? This example. So now we have A, right? So this is my A. And then I'm going to use the A, right? And then square bracket. And then this is, this is C is what? This is like vector, right? So index 3, 1. Oops. So that means, so this means, right? So first, that means third and the first row, right? And then this means second and third column, right? Because starting number is a 2 and ending number is a 3. So it's obviously what? It's a second and third column, okay? So just close, and then let's run. Okay, so it's 2 by 2 matrix. Okay, so and this, you can also identify the value along the diagonal, right? Diagonal of the square matrix. So if the matrix is square matrix, right? Let's say 3 by 3, 4 by 4, and 5 by 5, right? Then using this R built-in function, right? Diagonal, right? Then you can get this diagonal value. Okay, so this is obviously as you can see, this is not a matrix. This is a vector. Okay, now the next topic is omitting and overriding. So basically, to delete or omit the elements from the matrix, you again use a square brackets, but this time you have to use a negative indexes, right? So this means you return A, but without what? Without second column, right? So provide A without the second column. So you use a negative value. -2 means please remove the second value and from A and then returns it, right? So this is the result, okay? The following, remove the first row from A, right? So this is like remove the first row from A and retrieve the third and the second column value. So this is like retrieve second and third column value, and then you can get the matrix, okay? So now this one is obvious, right? Produce the matrix, right? Without the first row and the second column, right? Without first row and the second column. So, well, I think I like the, okay. So next page is, let's just delete to clear the screen. Okay. So that's like a negative, right? Negative, you use a negative. And this means delete the what? Delete the first row, right? Delete the first row. And then delete the second and third column. So this means delete the second and third columns. Okay? So that's about omitting or the removing, right? And now we are talking about overriding. Okay? So if you want to override the particular elements or the entire row of the columns, you identify the elements to be replaced and then assign the new values. So basically, you use this, right? So now this means, you know, will just B, right? Get the copy of A, and then, you know, the B will get the copy of A. So, for example, if you want to create another matrix that exactly same as A, then you overwrite, right? And so A, oops, right? Okay, run. And now I type B, and then you see that, you know, B has the exact copy of A, right? So that's like overwritten, right? The following overwrites the second row of B, with a sequence of 1, 2, and 3. So basically you can do some operation. So basically this, if you want to change the content, if you want to overwrite the second row, right? So you put the second row, right? And then with the sequence number 1, 2, and 3, right? Then you know that it's set, if you look at the second row, it has been changed, right? So for example, for me, let's say I have a B, right? And then I'd like to change my third row, right? So this is my B. Let's say I want to change this. Right now it's 369, right? I'd like to change to, let's say, what? 10, 11, maybe some sequence number. Let's say 15 through 17, or maybe 12 to 14, right? So let's just do that. So what I'm going to do is I'm going to change the, I want to change my second row, right? Second row, right? With some the vector, right? Sequence. And let's say 12 through 14. Okay, so that's something that I like to the change, right? Change the second column, second row of the vector B. Not the vector, sorry, matrix B, right? So I'm gonna execute this, right? And then let's look at, now let's look at the contents B, right? And then run and see my second row, right? The B's second row has been changed to 12, 13, 14. Okay, so the previous value 256, these previous values have overwritten. Okay, and this is like another example. Like this means that basically the second column, right, overwrites the second column elements of the first and third row. So this means what? First and third row, right? And then this is what? This is the second row. So basically, by looking at this, the two elements in a matrix B will be changed, right? 2, right? Because 1 and 3, right? And then the second, basically the second column elements of the first and third row. So basically, 2 elements in the matrix will be changed. As you can see, 900, 900, right? Okay. And this one is basically, replace the third column of B and with the value in the third column, right? Okay, so this is like another example, right? Okay. Let's see. Oh, you know what? Actually, you can also, when you do overriding, this vector recycling, right? This concept of recycling is also used here. For example, right? This is okay. You know what? Actually, let's first talk about this example, right? I want you to know that it's a vector of the length 2. Okay, so okay. Before we're talking about this recycling concept, let's talk about this example first. Okay, let's just I want to discuss this example first, because this really shows that, right, when you replace a value, right, the replacement takes place in a column-wise fashion. Okay, so that's important. So now let's take a look at this example. So you want to overwrite, right? So first you want to overwrite, and then you want to overwrite the first and the third row, right? And then second, and this means second and first the columns, right? So how many elements in total? So basically the 4 elements, right? So the 4 elements will be changed. And so this replacement, right? Okay, so now if you look at this, right? The 60, so first the column-wise fashion, right? So what that means is the first row, right? The first row and then third column, right? So basically, when you look at this, okay, so I think I need to use a pen. Okay, hold on. to explain this. Okay, so I said it's a columnized fashion, right? When the replacement will take place, the replacement will be done in a columnized fashion, right? See the columnized fashion or the columnized. Okay, so what that means is, so you know that this is what the first row and the third row, right? And then the second and first column. So it's the total of 4 elements. So the first row and then third row, right? And then second column and then first column, right? So first, this 65 and minus 65, the 65, right? The first column, right? And then what? This second row, right? So you know this, and then this will be minus 65. So you see that it's what? It's a columnized fashion, right? Replacement, as you can see, the replacement done in the columnized fashion. The next will be replaced. So next is this guy, right? So it's starting with the second, right? So it's starting the second. So this takes place first in a columnized fashion. And then the next is what? First column, right? So the first column is also a columnized fashion. So the 88, so you see that 88, and then a minus 88, so a minus 88. Okay, so that's what they mean by columnized fashions. Okay, now go back to the first example, right? So if you look at the first example, they're using the concept of recycling. So you know that this is what? This is the first and the third row, right? The first and the third row. And this means the first column and third column, right? The first column and then third column, right? So, but it has to be done, this replacement has to be done in a columnized fashion, right? So, but has the total of the, this means total of the four elements has to be replaced. But you only have only 2, right? So, remember the recycling concept, right? So basically, you have to assume that there's another 7, minus 7 actually, and then there is another 7, right? So this is the recycling, right? Okay, so but it has to be done in a columnized fashion. So first minus 7 and 7, you see, columnized fashion, minus 7 and then 7, right? And then this will be used. So this is the recycling, right? And then minus 7, and then minus 7 and then 7, right? So this is a columnized fashion. Okay, so this is what they mean by replace the 4 elements in a columnized fashion and etc. Okay, and then so this is a concept of the recycling. Okay, so let's clear this. Okay, so next topic is, so basically this is like a change the diagonal of the matrix B. So please try this example, okay? Do not just watch my video tutorial, please play with the sample code, right? And then you must do some experiment. Okay, now, so basically now let's talk about this exercise problem, okay? So construct the store 4x2 matrix that filled row-wise with this value, right? In that order. So in this case, important thing is they said we have to do it right row-wise, right? So that's the word that you have to pay attention to, right? Okay, so so basically you need to first create the 4x2 matrix, right? If you look at the part A, right? And so basically they're saying that construct and store 4x2 matrix that's filled. This is row-wise, right? And then they give the value. They basically the data is given, right? Okay, now all the numbers are given, right? So instead of using this number, I'll just use 1, 2, 3, 4, 5, 6. Okay. So now the 4x2 matrix, right? So that means how many elements? It's 4 times 2, so a total of 8 elements, right? So they have to store. So I'm gonna just create some the variable, right? So let's see what I'm gonna just call it just matrix, let's say C. Okay, my maybe, you know, or like, you know, matrix A. Okay, met A. I mean, you can come up with your own variable name, right? You can choose any variable name. So met A, I'll just use the matrix A, right? And then I need to use a matrix function, right? And then data is equal to the vector, right? And instead of using this number, you know, I'm gonna use 1, 2, 3, 4, 5, 6, 7, 8, right? 4 times 2, so it's 8. No. So these numbers, I don't like this number, so I'll just use 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, right? So there's 8 elements. And then what? The row, right? Dimension of the row is 4, right? And then the column dimension should be 2. And they said row-wise fashion, right? So the row-wise fashion has to be true, right? Okay, so that's the basically the answer, right? So let's just run this, and then I'll say met A and just check. Okay. Yep. So this is a 4x2 matrix, and then as you can see, it's the matrix is constructed in a row-wise fashion, right? You see that 1, 2, and then 3, 4, 5, 6, 7, 8, right? So row-wise fashion, because I just make this as true. Okay, now the part B. Conform the dimension of the matrix A, right, from A 3x2 if you remove any one row. So you know what? I'm going to remove, let's see. I'm going to remove, you know, second row. Okay, this row, right? So that means what? So to check the dimensions, I'm going to use function dimension, right? Dim. It's a built-in functions, right? And then for the argument, matrix A, right? And then to remove the second, so I need to use a negative, right? Negative number. So that means I'm going to remove, they said any row, right? So I'm going to remove the second row, or maybe you can remove the first row. It's either way. And then, yeah. So leave the column field blank, right? So if I remove this, it should be what? 3x2 matrix, right? So let's just run this. Yeah, this is what? 3x2 matrix. If I remove the first one. Okay. Now, let's see. And overwrite the second column of the matrix A. So this is my matrix A, right? Overwrite the second column of the matrix from A with that same column, sort it from the smallest to largest. Okay, so okay, now does that means you need to first sort the second column, right? And then that value, right? This value has to be overwritten to the original matrix. Right, so the first thing that is, I have to what? I have to first sort from the smallest to largest, right? So I know that I have to use a sort function, right? And then for the argument, met A, right? And what? Let's see, overwrite the second column, right? Second, so I have to just, row is empty, and then second column, right? So basically this, right, this will sort the second column of the matrix A, right? But so original, right, overwrite the second column of the matrix. The original matrix has to be overwritten with this value, right? So this is like overwritten, right? We learn about overwriting, right? So the met A, right? And then just leave the blank. And the second column will be replaced by this value, right? So basically, yeah. So let's see. I'm going to run this. and then I'm gonna see the mat A and see what happens. Okay, so now originally, right? So let me just, okay. So I want to look at this, the original mat A, right? The mat A. Okay, but you know what this case is, unfortunately, you're not gonna see any change. The reason is, if you look at the original, right? Original column, right? Second column is already sorted from the smallest to largest. So even though you apply the sort function, it's gonna be same, right? So that's why you're not gonna see any change, right? I think I choose the wrong example, but anyway, I mean, this is how you should do, right? You have an idea, right? So basically, this is the the problem C. But in our case, if you look at the original, like matrix A, right? Original matrix A, the second column is already sorted. So even though you apply the sort function, you know it's pretty much the same. Okay, but anyway, okay. So that's our part C. And now let's look at the part D. Okay, hold on. Let's just clean this screen. Okay. Okay, so that means, let's see. I need a pen. Okay, so they said delete the fourth row, right, and the first column. So basically, so this is your A, right? The matrix A, mat A, and then they are saying that what? Delete the fourth row. So delete this guy. And then delete the first column. So delete the first column. Okay, see what happens, right? So let's see. So the mat, right? Mat A. And then you know that the fourth row, right? So -4, right? And then -1, right? So the negative means removing, right? Okay, so now let's just see what it returns, right? Okay, so it returns. Okay, you know what? Okay, so this is I think this problem. It's subtle, right? Well, okay. So let me explain. Okay, so if you look at this problem, right? Okay, so let me just explain this problem. So remember, like, we remove the fourth row, right? And then remove the first column. So this is what happens, right? So what you have is basically this, right? But when you execute this command, right? Since this is this is the one column actually, right? When you remove the first, the fourth row and the first column, basically it's what is really remaining is just one column, right? So that's why what their return is what this is. Return value is what? This is not a the matrix, right? This is what? This is a vector, basically, right? This is a vector. Since there's like only one column. Okay, so that's why it's a vector. That's something that I want you to know. And that's why they say they use the matrix to ensure the result is a single column matrix. So since this is a vector, you have to change this value, right? This return result, right, into a matrix, right? Using what? Using the matrix functions, right? So basically, let's just clean. Okay, so basically what it means is, basically you have to use a matrix, right? And then you can use the data is equal to, or you can just use the, you can just use what? You can use this guy, right? So this is basically what? This is basically the vector, right? And now you want to convert this vector into this matrix. So the mat A, -4 and -1, right? Okay, so that's what they are basically asking you to do. So let's run this, right? So this is what? This is a vector, right? But now this is what? This is a matrix. So that's what they are basically saying. And you know what? Since you do not really specify by row, right? So default is what? The matrix will be constructed in a column-wise fashions, right? Because that's the default value. So by row is false, right? So by default. Okay, so that's like a part D. Now let's take a look at the part E. Store the bottom 4 elements of the C, right? And as 2 by 2 matrix. Store the bottom, right? So I'm going to create any just variable, right? Since I need a variable to store, right? So I'll just say what? The mat A, right? Mat A, also just 2, which is new. And then what they are saying is the bottom 4 elements, right? Store the bottom 4 elements. Let's see. Okay. So when you look at the C, right? I think this is a C, okay? And store the bottom 4 elements. So basically, bottom 4 elements is this guy, right? So that's the bottom 4 elements. So to do that, right? It's mat A, right? So basically the third and the fourth row, right? Third and then fourth row, and then every column, right? So pretty much, okay, so that's it. Okay, and let's just execute this, and then let's just print out mat A2. Okay, see if our solution is correct. Yeah, so it's a 5, 6, 7, 8, right? So this is correct. Okay, I'm gonna skip F. Okay, so basically I'm done with this section, right? Okay, so thank you.